Hi everyone, welcome back to the Sun Devil Learning Lab. My name is Miss Alford and today we are going to be discussing the Pythagorean Theorem. So with that, let's get started. Okay, so just like we start off any other video, feel free to get out a pencil, a piece of paper, a notebook, maybe you've been writing some notes in, or anything like that. And then also for this particular lesson, if you have a small calculator or any calculator really in general, go ahead and pull that out because we might use it throughout the lesson, maybe not, maybe you just want to do different things in your head, but feel free to grab that too if you would like. Okay, so the objective for today is I can understand the Pythagorean theorem and use it to find missing sides of a right triangle. So we're going to be talking all about the Pythagorean theorem and looking at some different examples and finding missing angles. So some important vocabulary before we get started with the lesson. First word is congruent. Congruent means when two figures have the same shape and size angles, or if one has the same shape and size as the mirror image of the other. So that could be maybe two different triangles are mirrored images of each other. They might not look the exact same or like be able to hover over one another and be perfect, but if they are congruent mirrored objects, they're going to be the same shape and have the same size angles. And then a right triangle. A right triangle is one that has one angle that measures 90 degrees. So if you look at this little picture I have to the right on the bottom, this triangle ABC, if you look in the C corner, C vertex, that is where the 90-degree angle is going to be. We see it with the square mark. That shows us that that vertex or that angle is 90 degrees. So we have in order for it to be a right triangle, it has to have one angle that measures 90 degrees. This definitely isn't 90 degrees, and this isn't either, but it does have one that is. And then converse. The converse is going to be the reverse of something or the reverse of really anything. We'll get more into that when we discuss the converse of the Pythagorean theorem. All right. So maybe this is definitely something you've probably heard of before. Maybe you've seen the equation. So once we start talking about it, it'll become more familiar to you. But the Pythagorean theorem states if the lengths of the legs of a right triangle are A and B, and the length of the hypotenuse is C, then we can use this equation, A squared plus B squared equals C squared. Okay, so that might seem like a lot, but we know that for this theorem to be true, it has to be a right triangle. I've bolded that. And then the legs consist of A and B, and our hypotenuse, which is going to be the longest side of the triangle, is going to be C. So that jumps to the next one. So keep that on the top of your head. Given a right triangle A, B, and C, A, B, and C, with C being the vertex of the same right angle. So we know that this is a right triangle because it has the 90-degree angle right there. Then the sides AC, A and C, and B and C are called the legs of this triangle ABC. And AB is called the hypotenuse of the triangle A, B, and C. So we just said, if we go back to the first bullet point, we know that little a right here and little b are our legs of the triangle, and our C is the hypotenuse. So that's also going to be the longest side of the right triangle. But in this second bullet point, when it says AC and BC, we know those sides by how whoever's writing the problem writes them out. So A B, so big A to big B, is going to be also the same thing as side C. So we can either, when we're filling in our equation, a squared plus b squared equals c squared, it's easier to do that than to write each of these, like b and c plus a and c is equal to a, b. So that's just a little bit about the Pythagorean theorem. So maybe this is starting to refresh you. Maybe you're starting to understand or remember, things are coming back to you, which is great, because we're going to do some examples and play around with the Pythagorean theorem a little bit. But just remember, a squared plus b squared equals c squared, where our a and our b are going to be the smaller sides, and those are our legs. And then c is the hypotenuse, which is also going to be the longest side of the right triangle. So a little bit more about this theorem. Let's take note that the side A is opposite the angle A. So you see that? A, that is the side that's opposite the angle A. Side B is opposite of the angle B. And side C is opposite the angle C. So whenever we go to fill out the questions, A and B are pretty much interchangeable because they're both considered legs. But our C and our hypotenuse is always going to be the one that we have to make sure we know and we're on top of making sure that it's correct. Because we can add together A plus B or B plus A, but we can't mix up our C. And the C in the hypotenuse, also known as C right here, is always diagonal from the right angle. So like we said, our C is opposite, our C angle is opposite of the side C. That's always going to be true because our hypotenuse, the longest side, is always going to be diagonal from our right angle. So if that maybe helps you when we're looking at the couple of problems, to remember, okay, I see the right angle, I see the 90 degrees, the hypotenuse is always going to be diagonal of that angle. Okay, so now that we've had a chance to get a good idea of what the Pythagorean theorem is, now we're going to back it up a little bit and talk about some facts, do a little discussion, and then kind of lead up to the Pythagorean theorem. So first of all, we are going to go one by one. So congruent triangles have equal areas. So this was what I was saying before. We have congruent being the same. So we have one triangle right here. This one is not a right triangle, but it is congruent. So we have a triangle, and it's as if there was a mirror right here, and it flip-flopped to the other side. So these angles are going to be the same. These sides are going to be the same. So congruent triangles have equal areas. Well, this is the same thing as this, so it's going to be equal. And then all corresponding parts of congruent triangles are congruent. Well, like we said, it's basically a mirror image. So this side is equal to this side. This angle right here at A is going to be the same one for the other one on the other side. All of these sides are going to be congruent. So that is also true. And then we have the triangle sum theorem, which says for right triangles, the two angles that are not the right angle have a sum of 90 degrees. Well, we kind of discussed this already. So going back to this picture that we had on the other slide, we have our 90-degree angle at our C. And we have our hypotenuse, which is across from that. Noted, remember we talked about that. Well, if we know that a triangle has 108, the amount of degrees in it is 180, and there's already 90 degrees that this angle is, then that means angle B and angle A have to add up to be 90, because 90 plus 90 is 180. So that's what the triangle sum theorem is saying. For right triangles, which we have our right angle, the two angles that are not the right angle, so our B and our A, have the sum, so added together, of 90 degrees, making this triangle 180 degrees in total. Okay, so this problem is called a square within a square. So we have a square, big square, and then we have a little square. The outside square has the side lengths A plus B, and the inside square has side lengths C. So this one's easy. The smaller one, side C, side C, side C, side C. And then for the big one, it's not just all B, it's this little part is B and this little part is A. So one side is A plus B. So the outside square has the lengths A plus B, and the inside square has side lengths C. So we are going to compare the area of the outside square with the parts it is composed of. 4 triangles and one smaller inside square. So we have one triangle here, one triangle here, one triangle here, and lastly, our 4th triangle. And then we have our smaller square on the inside. And we're going to compare these. We're going to compare the areas. We're going to compare the sides. We're going to compare the angles. So let's get started. What is the area of the outside square? Well, we know to find the area of anything, we take one for the area for a square or a rectangle is multiplying the length times the width. So for in this case, they're both going to be squares. So our sides, we're going to multiply together. So we have A plus B times A plus B. So A plus B squared, which is also going to look like A squared plus 2AB plus B squared whenever we distribute this. So like we said, the area of the outside square is going to be A plus B squared because we have, those are our sides. So the question is, are the 4 triangles congruent? Well, let's see. They have side A, side B, and side C for that triangle. Side A, side B, side C for that angle. And these are all the same. They're squares. They're going to have the same angles for each of them. All 90 degrees we can see right there, all 4 of them. And they have the same same size sides. So yes, they are going to be congruent. They're the same shape, they're the same size, and they have the same angles. Does each triangle have the same area? Yes, we talked about that in the previous slide. If triangles are congruent, then they have the same area and they will have the same size, shapes, and angles. What do we know about corresponding angles of congruent triangles? Well, let's think about this for a second. What do we know about corresponding angles of congruent triangles? Well, corresponding angles means that they're going to have what we see here. Go back. Corresponding angles means that we have our 90 degrees in the middle, we have some angle here, and this 90 plus this angle makes this have to add up to 180. We have a straight line. So we have 90 plus something plus something. Now we have a straight line, so we have our 180 degrees. Those are corresponding. Therefore, whenever like the red is shown here, is going to be the same thing over here, because these on the side B to C, that angle corresponds, it's the same. This A and C, the smaller one, A and C is going to correspond and it's going to be congruent, which that means they are the same. So the sum of the measures of the interior angles of the triangle is 180 degrees. So like we said, we have a straight line right here. We have our 90 degrees. So 180 minus 90 is 90. That means these two angles have to add up to 90 degrees. So for right triangles, one angle will measure 90 degrees. Like we said, that one's going to be this one in this case. And the sum of the two other angles, our blue and our red, will be 90 degrees. That is the sum between the two. So since the angle with the red arc and the angle with the blue arc must have a sum of 90 degrees, then that means the unknown angle must be 90 degrees. And we kind of already know that because we know when we see a square in the corner that it marks that it's a 90-degree angle. But this just really shows that this leaves, because of these angles, it really leaves the fact that these are not 90, but they add together to get 90. And we have our 90-degree angle in the corner. Which means that the square with the sides length C must be a square. And the area of the square is C times C, which is also C squared. So when we've seen these angles, we have corresponding angles right here. We know that even if we didn't pay close attention to these green squares, we know that these corners have to be 90-degree angles because it is a big square. Just the outskirts is just a big square. So we have our 90 degrees in the corner, and that leaves us knowing, okay, well then, in order for it to be a triangle, it has to add up to 180 degrees. We know it's a right triangle, so one angle is already 90 degrees. Well then our two other angles, our blue arc and our red arc, have to equal 90. Well, that means if these equal 90, then, and these are congruent triangles, then this is going to equal some number, 90 plus blue arc, which leaves red arc to get to 180. So these all correspond and they're congruent. So whatever we see is true for this triangle is true for this triangle and is true for this triangle. Well, what this is saying is that we know that this is a right triangle, and our hypotenuse, which is our side C, also our longest side, is the side of a smaller square. And C times C gives us the area of our little square, which is also C squared. So we can also do this by starting off with what we had come up, A plus B squared. And remember when I said we use the distributive property to break it up a little bit, A squared plus 2AB plus B squared. Well, that's also the same thing as saying 2AB plus C squared. Well, then we want to get C by itself because that's part of the Pythagorean theorem. So we're going to subtract 2AB from this side and subtract it from this side, where we're left with our A squared plus B squared equals C squared. So although we went through that entire process, we got down to the fact that we have our Pythagorean theorem. The A squared plus the B squared gives us our C squared, with corresponding angles, with congruent triangles, and with our 90-degree angles. So now we're going to start with an example. If the lengths of, this is just reiterating, if the lengths of the legs of a right triangle are A and B, and the length of the hypotenuse is C, then this equation holds true for the Pythagorean theorem. A squared plus b squared equals c squared. So we want to determine the length of the hypotenuse of this right triangle. So we have a leg over here and a leg over here. So our A, so 8 squared, and our 6 squared. We're going to add those together to get the length of our hypotenuse. So maybe pause the video for a second and try, maybe you copy this triangle down. Maybe you start trying to plug in numbers for the a squared plus b squared equals c squared, or just think about, make the connection of the right triangle to, is going to be diagonal of the hypotenuse. Okay, so we have our same problem, our triangle ABC, and our Pythagorean theorem, a squared plus b squared equals c squared. Well, now we have written in our side A, our leg A, and our leg B. So 8 squared plus 6 squared equals c squared. Well, remember I did say too, if you wrote this out in a different way, maybe you said 6 squared plus 8 squared, that is totally okay, as long as the legs are being added together. So you could do a plus b or b plus a, as long as it equals c, the hypotenuse. So 8 squared is going to be 64, and 6 squared is going to be 36. So 64 plus 36 is going to be our c squared. So 64 plus 36 equals 100, and that is our c squared. And I know you guys learned before that when you have a squared number, the opposite of a squared number is the square root. So the square root of 100 is 10. So our side C is going to be 10. And like I said, it does not matter which leg is A or B, as long as both numbers are only used once. So if you wrote this in a different order, 36 plus 64, that is okay, because you're still going to get the same answer of 100, which is our C squared, and our C, side C, is going to end up being 10, because 10 is the square root of 100. Okay, good job, guys. Let's move on to the next example. So example 2, we have our A, B, and C. We have our right angle here, our hypotenuse diagonally across from it, and then a side leg that is 5, and then another leg that is 12. So take a second to, maybe this is where you pull out your calculator, pause the video, and do the math on your own. Fill this in and try to figure out what C is. Okay, so a squared plus b squared equals c squared. We've got that like ingrained in our brains now. We have, I chose to do 12 squared plus 5 squared gives us our c squared. Maybe you wrote it as 5 squared plus 12 squared. That is perfectly okay, as long as they're only used once, and they are our legs A and B. So 12 squared is 144, and 5 squared is going to be 25. So 144 plus 25 equals our c squared. So our c squared equals 169. C squared, we want to find the square root. So the square root of 169 is 13. So you see too that our numbers are going to be bigger for the hypotenuse. We have our 5, our 12, and this is always going to be the longer side or the bigger side, and it's 13. So if there's never going to be the case where maybe this one's 13 and this one is going to be 12, because the hypotenuse side C is always going to be the longest side. Okay. So now we're going to talk a little bit about the converse of the Pythagorean theorem. So we learned a squared plus b squared equals c squared. Well, let's think about it the opposite, or the converse, the reverse way. If the square of the length of the longest side so that's our hypotenuse, c squared, of a triangle is equal to the sum of the squares of the two sides, the two legs, a squared plus b squared, then the triangle is a right triangle. So we just wrote this equation, or the equation differently. We have it backwards. So c squared equals a squared plus b squared. So the length of the longest side is going to be equal to the sum of the squares of the other two sides. And if this is true, then it's a right triangle. So let's go over an example of the converse. So for this one, we have our right triangle right here, C, and across from it, we're actually given our hypotenuse of 0.5. And then we're given side A. So this one tells us it's side B. So side A is 0.4, but we don't know our B. So we're going to have to do this a little bit differently than just adding together A and B to get our C. So we're going to use this equation, c squared equals a squared plus b squared. So we have our c, which is 0.5, and we have our a, which is 0.4. We don't have our b, so 0.5 squared equals 0.4 squared plus b squared. Well, now what do we do? Well, we know 0.5 squared is going to be 0.25. So we're doing the math. We're multiplying each number by its square. So 0.25 equals 0.4 times 0.4 is going to be 0.16 or 0.16. And we still don't know our b. Well, what now? Well, we want to get b all by itself because that's what we're trying to figure out. So we are going to subtract our 0.16 from this side and subtract it from this side to get b all by itself, which then gives us 0.09 equals to b squared. And we're not done yet because we still have a square. That means we need to find the square root. So the square root of 0.09 is going to be 0.3. Therefore, our b, one of our legs, is going to be 0.3. So that might have been confusing. That might have been harder than the last problems that we've been doing, the last examples. But if it was, then pause the video and kind of just like go back through this and like watch it again, maybe take some notes, really mark where we subtracted the 0.16 from the right side and also subtracted the 0.16 from the left side to get 0.09. So it's a little bit different, and this is us doing the converse of the Pythagorean theorem. And so now we're going to do one last problem. And it's kind of a big problem, but I have faith in every person. So this triangle does not look like any one that we've looked at yet. We have, in fact, two triangles, which makes one big triangle. But I don't know about you guys, this Q, R, and S, I don't see any right angles. I see a right angle there, but that's not the big triangle overall. Well, this one we're going to have to do a little bit differently. In order to find the hypotenuse of QRS, this triangle QRS, we have to look at the two separate triangles, QR and T and RS and T. So in this case, we see this right angle right here, this 90-degree angle. Well, these are corresponding angles, and this is a straight line, meaning that this is 90 degrees, therefore there's an imaginary 90-degree angle right here because they correspond and they equal 180. They are the same and they correspond. So we have two right triangles. So if we use these two numbers, 15 and 25, then we can find this leg. And if we use 17 and 15, then we can find this leg. So we will find Q to QT and TS and add them together to get our QS for the entire side. So let's get started. For QRT, our equation looks like this. So we are looking for QT. That's what it says, Q to T. So we're going to do, we have our C, our hypotenuse. Imagine there's a 90-degree angle right here. Across from that is going to be, diagonal of that is going to be our hypotenuse. So we have our C. This one's going to be the converse. So we have our C squared first. C squared equals, we have one leg, maybe it's A, 15 squared. Oh, no, this one's going to be B. Sorry, guys. Plus some other side that we don't know. So that's going to be our A squared to get our QT, to get this side. Well, then for the triangle RST, we're going to do the same thing to get this TS. We're going to take 25 squared, which is our hypotenuse, diagonal of the 90-degree angle, which is equal to 15 squared, side B, plus our A squared. And this is going to give us TS. So now we're going to do the math. And if you want to pull out your calculator, feel free to do so. We are just going to start going. Feel free to write this down. Feel free to take a closer look at this triangle that we have posted up here on the right, top right. But pause the video if you'd like to do the math on your own. But let's see. So for QRT, our equation looks like this. Like we just said, 17 squared equals 15 squared plus 8 squared. 17 squared is 289, and then 15 squared equals 225. And then we still don't know our A squared. Well, now we're going to go from, we want to get our A squared by itself. And I didn't write it here, but I want you to really pay attention to the fact that in order to get A squared by itself, we have to subtract 25 from both sides. So we subtract it from this side, and then we subtract it from 289, and that gives us 64. So our A squared is going to be equal to 64. Well, that's just a square. We need to find the square root. So the square root of 64 is going to be 8. So we have our Q to T, which is 8. Okay, Q to T is 8. Now we need to find T to S. So we said our equation to find this side is going to be 25, our hypotenuse, equals 15 squared plus 8 squared. 25 squared is 625. And 15 squared is going to be 225. And we still don't know our A squared. That's what we're looking for. Well, like we said, we want to get A squared by itself. So we subtract 225 from one side. What we do to one side, we do to the other. So we subtract 225 from 625, and we get 400. And 400 equals A squared. Well, are we done yet? No. We need to find the square root of 400. The square root of 400 is 20. Therefore, 20 equals A. A, the side A over here for this, T to S equals 20. So for the big triangle, Q, R, and S, our hypotenuse, Q to S, is going to be QT plus TS, which gives us our big QS. So Q to T is 8, T to S is 20. Together, QS equals 28. So that got a little bit confusing. There was a lot to that problem. We had to do the converse for the Pythagorean Theorem 2 times in order to find the hypotenuse for one big triangle. So we got to keep making those connections on where is the right triangle, and where is the hypotenuse, and what is it that I'm looking for. So that is kind of the end for the examples and the problems that we're going to work on. But I do want to do a little discussion, another recap. So the Pythagorean theorem is for right triangles. And in order for something to be a triangle to be a right triangle, it has to have one 90-degree angle, and then the other two angles have to add up to 90 degrees because there is 180 degrees in a right triangle, in triangles in general. And the equation we use for our Pythagorean theorem is a squared plus b squared equals c squared. So right triangles have sides, A and B, those are known as legs, and we said those can be interchangeable. They don't have to go in any certain order. If you think one of the legs is A and the other one is B, then go for it, as long as they are only used once and they are always the legs of the equation. You can flip-flop these two, B plus A or A plus B, but this C, this hypotenuse, is always going to be, that can never be switched around with a different number. So right triangles have sides A and B, known as legs, and a side C, known as the hypotenuse. And we know the hypotenuse is always going to be the longest side, and it's always going to be diagonal of the 90-degree angle. And then the converse of the Pythagorean theorem is going to be where our c squared, our hypotenuse, equals a squared plus b squared. So it is just the reverse of the Pythagorean theorem. And then lastly, if you guys want some more practice working with these triangles and working on problems in general, feel free to go to the learning guide and go to the bottom and click on this link at Engage New York and complete pages S85 and S86. I appreciate it so much for you guys sticking around and watching this. I hope you learned, and maybe it was like a review for you with the Pythagorean theorem, and maybe you had never heard of this before. So I hope you were able to learn something, take something away from it, and feel free to get more practice wherever you feel. But specifically, I connected this link for you guys to go and be able to get some more practice in. So thank you guys so much, and I hope you'll have a great day.